Today in this video, we'll learn about nodal analysis. So the objective of nodal analysis is to solve a circuit using nodal analysis, which is the application of Kirchhoff current law, or known as KCL. So we're going to go through this by trying to tackle an example, an exercise, an example of an exercise, right? So let's say if you have a circuit. I'm going to draw this circuit. You have a voltage supply US, and then it's connected to two resistance called R1 and another one R2, right? And then on the other side, you'll have another loop where you have another current supply IS, and let's say the values are unknown, and I give the value US is 10 volts, R1 is 10 ohm, and R2 is 5 ohm, while IS is 1 ampere, right? So what do we need to find now? So the thing that we need to find in a circuit is, of course, to deduce what are the voltages and the current across the whole circuit. So first, can we identify what are the voltages and the currents that is not available that we have to find? The first one would be, of course, you can see that across the resistances R1 and R2, we can write UR1 and UR2, the voltage across the resistances. And of course, by doing so, you can also try to find IR1 and IR2, the currents that goes through R1 and R2. So how do we do this using nodal analysis? The first step to do is to identify the nodes. In order to use nodal analysis, it applies the KCL law. So remember, KCL law talks about current. It is on current, and when we want to use it, we have to first and foremost identify where the nodes are. So first thing is identify the nodes. So where are the nodes? How many nodes do we have in here? We can see that there is basically one node over here. Let's say I'm calling this node as node A. Another one is over here, node B. And that's the final one, and the third one, which is node C, right? So there's node 1, node B, and node C. So what do we do next? We know by looking at the nodes, we have voltages between the nodes, right? UAB, between A and B, we have UAB, which is basically UR1. We also have UBC, voltage between B and C, which is UR2. And we have voltage between A and C, UAC, so here, which is basically US, right? So we can identify there are three voltages when we have three nodes. So next, what we need to do next is, the second step is to choose a reference. So what does it mean to choose a reference? Choose a reference means you have to pick a node to become a ground. So let's say here, what I want to do is to put the ground at node C. So what does it mean to put the ground? Put the ground means you're making it as a reference where you're considering that the voltage at point C equals to 0. So that all other voltages, U at B or U at A, will always be referenced to the point C. Let's say if I write UA is basically the voltage between A and C, UAC. And voltage, if I write UB, it is basically the voltage difference between point B and point C. So if I have to draw a line and draw an arrow of voltages, UA means the voltage that we have here between point A and point C, and UB is the voltage that we have here. So this is UB and this is UA, voltage between point A and C, voltage point B and between point B and point C. So that's UA and UB, right? So here is basically UA. So next, once we have chosen the reference, what do? We can see that here from the voltage that we write over here, there is basically two unknown, which we have basically previously identified as UR1 and UR2. UA between UA and UC is basically equals to US. Well, so UAC is, so that there is not two unknown. If we look at UAC between point A, let me highlight, between point A and point C, UAC, there is basically US. So we have now identified that UAC is basically US. So there is now not two unknowns, but only one unknowns, right? Okay, so now the only unknown is UB, which is UBC. If you look at UBC, what is UBC? Can we try to identify what UBC is? UBC is basically UR2. If you look UBC, let me highlight. The voltage, the potential difference between point B and C is basically UR2, right? So UB can also be written as UR2, right? Okay, now, so what's left is basically we have one unknown left. So this is the thing that we need to identify, right? So how do we identify this? So the thing that we need to do now is, of course, we go to, if we use nodal analysis, what we do is, the next step is write the KCL. On which node do we want to write KCL? We would write the KCL on the node where it will involve the most current. So to do so, we have to first and foremost identify the currents. So where are the currents? So we can see that I'll choose node B, and there is one current that comes here from the power supply into R1. I'll call this one as IR1. And there is another current that coming from the current supply IS. I'm going to call it as IS. And then there is, of course, resulting currents that go out of node B into R2. I'm going to call it as IR2, right? So the KCL that we can write is so what KCL says, the sum of current entering into node equals to the sum of current quitting the node. So IR1 plus IS equals to IR2. So get the basis of the equation on which we have to develop next to find the unknown. Okay, what we need to do now is to develop this equation. We don't know what IR1 is. We know what IS is, so this is known. We don't know what IR1 is, and we don't know what IR2 is. So what we need to do is to develop this equation. So what IR1 equals to? IR1, if we use Ohm law, it is equals to UR1 over R1, right? UR1 over R1. If we develop IR2 by Ohm law is equal to UR2 over R2. So now the next question is, so we have to continue and further the reasoning to solve the KCL. So what is UR1? The next question is, what is UR1? So where is UR1? If we look at UR1, it's the voltage that goes across R1. If I have to put the direction of UR1 would be in this direction, UR1. So how do we find UR1? if you want to find UR1, you can see that UR1 is basically in a loop here, in this loop, and we can use KVL in order to define what UR1 is. Let's say, let's go and let's do the KVL. So we have, if you want to do KVL, you have US on one side, all right? US on one side, and then you have UR1 on the other side. On the next branch, you have UR2, and then you complete the loop. So if we write the KVL becomes, what's the KVL? US equals to UR1 plus UR2, right? If you go through the loop, you see that it's US minus UR1 minus UR2 equals to 0. So I can write US equals to UR1 plus UR2. So what we want is UR1. So UR1 is US minus UR2. So now the question is, what is UR2? Right? What is UR2? And if we go here, so let me point it out. If we go here, what you know is UR2 is basically equals to UB, the unknown, the only unknown, right? So you can write it in terms of UB. Let's say, so it is now also equals to US minus UB. So now UR1 over R1 can be written as US minus UB over R1. So that is the unknown in this equation now. IR2, we go to the side, to the IR2 side. It is equal to UR2 over 2. And UR2 we know from here as well, it is basically UB. So this can also be written as UB over R1. So now we have one equation. So this equation of KCL, I call it as equation number 1. And equation number 1 can now be written as, so if I rewrite the equation once we have developed IR1 and IR2, it has now become US minus UB over R1 plus IS equals to the developed term is UB over R2. So if we look into this equation, we have one equation and with only one unknown, which is UB. So now we can try and find UB. So I'll leave it to you. I mean, okay, we're gonna try, we're gonna do it together, solve it. Right, so now, how do we develop this? Let's say I multiply everything by R1. So US minus UB plus, where's my marker? US minus UB plus R1 IS equals to R1 over R2 multiplied by UB. If I bring UB, all the UBs on one side, what happened? You'll have bring UB all on one side. I'll have so US plus R1 IS equals to UB multiplied by, so it's R1 over R2 plus 1, right? So now we can deduce that UB equals to US plus R1 IS over 1 plus, so it's 1 plus R1 over R2, right? So now you have find UB. So if we look back into the exercise, we know the value of US, right? We know the value of US, we know the value of R1, IS, R1, and R2. So if you do the calculation using the parameters that was given, which is US equal 10 volt, R1 equal 10 ohm, and R2 equals 5 ohm, as well as IS equal to 1 ampere, what you're going to find out is you'll find at the end, the answer will be UB equals to 6.67 volt, right? So that's the final answer for UB. So now you have find UB, right? UB, we have find what UB equal to, which is also UR2. So it's done for UR2 because UR2 is UB. What's left to be found is, let's say, UR1. What's UR1 equals to? If we go back to our development here, over here, we have seen that we we have found that UR1 is equal to US minus UB. So this is easy to solve. Once you know what UB is, so you can also find UR1, which is US minus UB. So we had US equals to 10 volts minus UB 6.67 volts. So UR1, you'll find it equals to 3.33 volts, right? And then the other parameters that we can find is basically IR1 and IR2. So this is easier now. IR1, you use Ohm law, is equal to UR1 over R1. IR2 is UR2 over R2. So if you take the values, you'll find that IR1 equals to 0.33 amps, while IR2 equals to 1.33 amps. Okay, so that's how we do nodal analysis in order to find out the parameters of the circuit. Let's say if I were to summarize everything, first step that you need to do is to identify the node. Second step is to choose a reference. This is very important in order to be able to write your voltages. Choose a reference. So how do we choose a reference? Reference is the point where you, at that reference, we choose C equals to 0, right? And how do you choose that reference? That reference is usually chosen at the point where it is the closest, or it is at the terminal of a voltage supply. So for example, here we have chosen point C because it is the point that is connected to the minus terminal of the voltage supply, right? And then next, once you have chosen the reference, the third step would be to write the KCL. And of course, at the end, once you've written the KCL, you develop your KCL and solve the equations. So that's all for nodal analysis, and I suggest for you to do different examples and exercises that you can find in the slide. So that's all for now. Thank you.